the common elements present in both the sets is called the intersection, and it is denoted as A intersection B, like this. A minus B union B minus A is called the symmetric difference, and it is denoted as A delta B. The set of all common elements which belongs to A and B is called the intersection of the two sets. Hello dear students, welcome to this session of Discrete Mathematics. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. So, in last class we have discussed regarding the definitions of sets and different types of sets. Now in this session I am going to discuss regarding the operations on sets. The operations on sets like union of sets, intersection of sets, and the difference of sets and the complementation of sets, and the problems as well as the properties based on those operations. Now let us come to the first one, the union of sets. Union is nothing but combination of all the elements. So if there are number of sets, if there are 2 sets, 3 sets, the combination of all the elements in the one set is called the union. Union means combining, clapping all the elements. So let us consider 2 sets. Let A and B are any 2 sets. Then the union of set A and B is denoted as A union B. This is called A union B, and is defined to be the set of all those elements which are in A or in B or in both. The elements which are in A or in B or in both A and B is called the union. So if A and B are any 2 elements of the set, then the union of this denoted as A union B is equal to a set such that X belongs to A or X belongs to B. A set X belongs to A and X belongs to B. So here all the elements which are in A or in B or in both A and B. Let us come to a small example. Let A is equal to A, B, C, 3 elements. B is equal to C, D, E, F. Now the union of these 2 sets A and B is denoted as A union B is equal to, write down the elements of the set A first. A contains A, B, C, and B contains already C we have entered, then D, E, F. So the union of A and B is set of all the elements which are in A and B and as well as in A and B. See here A, B, C is in first set, C is also in the first set we have taken. Now leave this, go to the next element D, E and F. So A, B, C, D, E, F are the elements of the set A union B. Now let us consider this set. If A is equal to 1, 2, 3, 4, 5 and B is equal to 1, 2, 3, 4, 6, 7 up to 9, then the union of this is nothing but 1, 2, 3, 4, 5 up to 9 is the union. Since this contains all the elements from 1 to 9, so we can write the union of A and B is 1, 2, 3, 4, 5, 6, 7, 8 up to 9. This is called the union. So in general, if A and B are any 2 sets, let me take one more element, one more example. If A is equal to 2, 3, 4, 5 and another set B is equal to 1, 6, 7, 8, then the union of these 2 sets is denoted as A union B is equal to, write down first 1, then we have 2 in order 3, 4, 5, 6, 7 and 8. This is called the union of these 2 sets. So the combination of all the elements in A and B will comes under A union B. Okay. Now let us come to the properties. Now union of 2 sets A union A is always equal to A. If you combine 2 sets of same form, A union A is equal to A itself and A union null set. So union of a set and a null set is the same set, and intersection. So I will explain what is intersection. If you go for intersection of a set and a null set, you will get the null set. So if A is a subset of B, then A union B is equal to B itself. So the properties are like this: A union A, union of A and A is same set, and the union of a set and a null set is equal to the same set A will get. Whereas the intersection, if you come to the intersection, A intersection null set is a null set. Whereas if A is a subset of B, if A is a subset of B, then union of B, A union B is always equal to B. Now let us come to the second operation, that is intersection of 2 sets. So intersection is denoted like this: A intersection B. So intersection is nothing but the common elements in both the sets A and B. The common elements will form a set that is called the intersection. So here, let A and B are any two sets. If A and B are any two sets, then the intersection of A and B is denoted as A intersection B and is defined by the set of all common elements belong to A and B. The set of all common elements which belongs to A and B is called the intersection of the two sets. So, that is nothing but A intersection B. If A and B are any two sets, then intersection of A and B is nothing but a set which belongs to A and the elements which belongs to B. All the elements which belongs to A and B, that is nothing but the common elements. All the common elements in A and B will form a set that is called the intersection and it is denoted as A intersection B. Now, let us take a small example. If A is equal to A, B, C, D, B is equal to C, D, E, F, G, H, then A intersection B. A intersection B is nothing but the common. A is here but A is not there, B is also not there, C is in the set A as well as B. We can take C as the common element, D is also in the set and D is also here. We can take C and D, whereas E, F, G are elements of the set B, that is not included in the set A. Similarly, A, B are the elements of the set, they are not included in the set B. The common elements are C, D. Therefore, A intersection B is equal to C, D. So, the common elements in these two is called the A intersection B, that is equal to C, D, intersection of two sets. Now, let us come to the one more example. Let A is equal to 1, 2, 3, 4, 5 and B is equal to 1, 2, 3, 4, 6, 7, 8 up to 9. Then the intersection of these two is nothing but all the elements of the set A, because A contains 1, 2, 3, 4, 5, whereas B contains 1, 2, 3, 4, 5, 6, 7, 8 up to 9. This contains 4 and 5. The common are 1, 2, 3, 4, 5, that is A itself. So, intersection of this and this set A and B, we are going to get it as A in this case. Okay. Now, in general, the intersection of two sets is nothing but the common elements present in both the sets is called the intersection and it is denoted as A intersection B, like this. Okay. Now, let us come to the properties of intersection. As I told now itself, intersection of two sets is equal to intersection of two sets means A and A. If you intersect, you will get the same set. So, A intersection A is equal to A. Similarly, A union A is also equal to A. A and a null set, if you intersect, the intersection of a set and a null set is equal to null set, because in null set there is no element. So, no element common in A and null set is a null set. So, intersection of A and null set is a null set. The union of a null set and a set is the set itself. A union null set is the set itself, whereas the intersection of a set and a null set is a null set. And intersection of a null set and a null set is again a null set, because no elements are present, then it is again a null set. So, if A is a subset of B and A intersection B is equal to A itself, if A is a proper subset of B, all the elements of A must be the elements of B, means then A intersection B is A itself. In case of a proper subset, if A is a proper subset of B, then A intersection B is equal to A itself. So, these are the properties on the union and the intersection of sets. So, very simple concepts, right? Now, let us come to the next one, the difference between the two sets, difference of two sets. So, the difference of two sets A and B is denoted as A minus B. A minus B is called the difference of two sets. And similarly, B minus A is also the difference of two sets. A minus B is the difference from A to B and B minus A is the difference from B to A. Now, let us come to the two sets. Let us consider two sets. Let A and B be any two sets. Then the difference A minus B is defined as set of all those elements which are in A but not in B. A minus B is nothing but this is the difference. If A and B are any two element, if A and B are any two sets, then A minus B nothing but all the elements which belongs to A and X does not belongs to B. That is, the difference A minus B is nothing but all the elements, set of all those elements which are in A but not in B. All the elements which belongs to A but not belongs to B is called the A minus B, that is called A difference B. I will explain once again. Let A and B be any two elements of any two sets, then the difference A minus B is defined as the set of all those elements of A which are not in B. Now here it is also called as the complement of B with respect to A. This A minus B is also called as the complement of B with respect to A. Similarly, B minus A is called the difference between B and A is nothing but set of all those elements which are in B but not in A, denoted as B minus A. B minus A means set of all elements which are not in A and whereas which belongs to B. Set of all those elements which are in B but not in A is called a B minus A. So these are nothing but it is also called as the complement of A with respect to B. Now let us take an example, very small example. Now you got an idea. A minus B. A minus B is nothing but set of all elements which are in A but not in B is called A minus B. Similarly, B minus A means set of all elements which are in B but not in A. That is the difference. Now let us come to this example. Let us take small example. Let A is equal to A, B, C, D. B is equal to D, E, F, G. And what is A minus B here? A minus B is nothing but all the elements which are in A but not in B. So A is here but not in B. Similarly, B is in the set A but not in B, and C. C is also here but not in B. So A, B, C is nothing but A minus B. So the difference between A and B is A, B and C. Difference means the elements which are in A but not in B. Difference, that's it. Now similarly, B minus A, elements which are in B but not in A. So here we have E, E is here, E is not in the set A. F, F is in set B but is not in A. G, G is here, H and I. So E, F, G, H, I are in the set B whereas they are not in the set A. Therefore, B minus A is nothing but E, F, G, H, I. So A minus B is A, B, C. B minus A is equal to E, F, G, H, I. These are the difference between A and B and B and A. A minus B and B minus A. Okay. Now, let us come to some symmetric difference. What is meant by this symmetric difference means? Let us consider two sets A and B. If A and B are any two sets, then the symmetric difference between A and B is defined as the union of A minus B and B minus A. So A minus B union B minus A is called the symmetric difference and it is denoted as A delta B. The symmetric difference of A and B is A delta B is equal to the union of A minus B union B minus A. A union B minus A minus B union B minus A is called the symmetric difference between the two sets A and B. Now let us come to a small example. Let us consider A. A is equal to A, B, C, D and B is equal to D, E, F, G, H, I. These are two sets. Now find out the difference. First find out A minus B and B minus A. A minus B. A minus B means all the elements which are in A but not in B. A minus B, A, B and C which are in A. D is also in both the sets. We can leave this. So A, B, C is A minus B. Similarly, B minus A. B minus A means all the elements which are in B but not in A. D is there. We can take D out. E, F, G, H, I. E, F, G, H, I are in set B whereas they are not in set A. So A minus B and B minus A. Now the union of these two. The union of A, B, C and E, F, G, H. The union. So the union of these two is A, B, C, A, B, C, E, F, G, H, I is the symmetric difference between the two sets. Okay, the union of A minus B and B minus A. Let me take one more example. I will take another example. Let us consider if A is equal to 1, 2, 3, 4. Another set B is equal to 3, 4, 5 and 6. These are the two sets. Now find out the symmetric difference. Before that, find out A minus B. What is A minus B? The elements which are in A but not in B. So A minus B is element 1 is in set A but not in this. 2 is here but not in this. 4. So 3, 4 are common. We can leave this. A minus B is 1, 2. Similarly, B minus A. B minus A means elements which are in B but not in A. So 3 is here, 4 is also here, only 5 and 6 is not in A. So A minus B is 1, 2, B minus A is 5, 6. Then the symmetric difference between these two is denoted as A delta B is nothing but A minus B union B minus A. So this is nothing but the union of this 1, 2, 1, 2, 5, 6. This is 1, 2, 5, 6 is the symmetric difference of these two. A minus B union B minus A is 1, 2, 5, 6. This is how we are going to find the symmetric difference A delta B. So, first find out A minus B. A minus B means elements which are in A but not in B. B minus A means elements which are in B but not in A. The union of these two, A minus B and B minus A, will give the symmetric difference that is denoted as A delta B. That's it. Okay. Hope you got an idea regarding union of sets, intersection of sets, difference of sets A minus B, B minus A, as well as the symmetric difference of the sets A delta B. Now, let us come to the next concept, that is called the complementation of a set with respect to universal set. Suppose if U is a universal set and A is any set, then the complement of set A is denoted as A dash, and that is given by this A dash is equal to U minus A, universal set minus A. The difference between universal set and the set A is called the complement of A, and it is denoted as A dash, or sometimes this can also be denoted as AC. Now, let us consider, let A be any set, let A is any set, then the complement of the set A with respect to U is a set of all those elements of U which are not in A. All the elements of U which are not in A, that is denoted as U minus A, or this is given as A dash or A complement. A dash or A complement is called the complement. The set of all elements which are in U but not in A is called the complement of A, denoted as A dash. Similarly, if it is B means U minus B, denoted as B dash. Now, let us take a small example. If A is equal to 1, 2, 3, 4 and another set U is equal to universal set 1, 2, 3, 4, 5, 6, 7, 8, 9. Then the complement of this is nothing but A dash. A complement is A dash is equal to U minus A. U minus A means all the elements which are in U but not in A. Let us take A is equal to 1, 2, 3, 4, U is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Then the complement of A is denoted as A dash is equal to U minus A, all the elements which are in U but not in A. So, here 1 is there, we can leave 1, 2, 3, 4. Other than this, the remaining elements 5, 6, 7, 8, 9 comes under the complement of set. A dash is equal to U minus A is 5, 6, 7, 8, 9. Suppose if you take one more element, one more set, say B is equal to 5, 6, 7. Then the complement of B is given by B dash is equal to U minus B. U minus B means all the elements which are in U but not in B. So, you can take 1, 2, 3, 4, 5, 6, 7 are not there, leave this, and remaining elements are 8, 9. So, A dash is this, B dash is equal to this. Depending upon A and B, we can write the complement of A and B, A dash and B dash. So, in general, the complement of a set A is nothing but the complement of set any set A is the universal set difference that particular set. U minus A will give the complement of that set A, and it is denoted as A dash or AC. Let us come to the properties based on union, intersection, and the difference, complementation, and symmetric difference. Now, very important laws, the commutative law. Commutative law means if A and B are any two sets, then A union B is equal to B union A. A union B is equal to B union A, and A intersection B is also equal to B intersection A. A union B is equal to B union A, or A intersection B is equal to B intersection A is called as the commute. They are commute to each other. A union B is same as B union A. Similarly, A intersection B is same as B intersection A. So, they are called as the commutative law. Now, let us come to a small example. Let us take an example. If A is equal to 1, 2, 3 and B is equal to 2, 3, 4, then find out A union B. A union B is the union of this is 1, 2, 3, 4. A union B is 1, 2, 3, 4, and B union A. B union is also equal to 1, 2, 3, 4. So, here what you say, A union B is equal to B union A. Similarly, let us take one more example. If you want the A intersection of B. So in the same example, if you write the intersection is 2 comma 3. The common in A and B is 2 comma 3. A intersection B is 2 comma 3. Similarly, B intersection A, B and A intersection is also 2 comma 3. A intersection B is also equal to B intersection A. So A union B is equal to B union A, or A intersection B is equal to B intersection A. Let me take one more example. If I take A is equal to A, B, C, D, another set B is equal to C, D and E, then the union, let us come to the first, A union B. What is A union B? A union B is A, B, C, D and E. Similarly, B union A. B union A. First, write down all the elements of B and C. C, D, E, A, B, C. So that is nothing but in order A, B, C, D and E. What do you say from these two? A union B is equal to B union A. So therefore, we can write A union B is equal to B union A in this case. A union B is equal to B union A. Similarly, if you find the intersection for this, for the same example, let us find out the intersection. A intersection B. The intersection for this, the common elements in A and B is A contains C, D and B also contains C. C comma D is A intersection B. Similarly, B intersection A. B and A intersection. B contains CD, A also contains CD. So the common elements are C and D. So what do you say from these two, C and D? So we can say that A intersection B is also equal to B intersection A. So A intersection B is equal to B intersection A. So this is called the commutative law. A union B is equal to B union A, and A intersection B is also equal to B intersection A comes under commutative law. Okay. Now let us come to the next law, that is called associative law. This is also an important. For any three elements, for any three sets A, B, C, if A, B, C are any three sets, then just interchanging the brackets, that's it. A union B union C is also equal to A union B union C. A union B union C is equal to A union B union C. Just interchange this bracket to A. A union B, C, here it is B union C, then it is A union B. A, how to read? A union B union C is equal to A union B union C. Similarly, in case of intersection, A intersection B intersection C is equal to A intersection B intersection C. This is very, very important law. You may expect one example question from this. Now, let us take a small example. Let us take if A is equal to 1, 2, 3 and B is equal to 2, 3, 4, 5. Now, let us verify the associative property for both. First one. Now, let us find out B union C. Oh, sorry, one more set I will take. One more set. C is equal to 4, 5, 6, 7. So, these are the three sets. Now, let us write down first B union C. B union C. Union of B and C is C 2, 3, 4, 5 and 4, 5 already is there. We can write 6 and 7. So, B union C is 2, 3, 4, 5, 6 and 7. Now, write down the LHS. The left hand side is A union B union C. A union B union C. All the elements which are in A as well as B union C. So 1, 2, 3 here other than 1 all the elements are there. First write down 1. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Let us represent this as equation number 1. Now, on the other hand, find out A union B. First find out A union B. Similarly, A union B is equal to, write down A and B union. So, the union of these two is 1, 2, 3, 4, 5. Then, next, right hand side RHS. What is the RHS? RHS is A union B union C. So, A union B contains 1, 2, 3, 4, 5, comma, union C. C contains 6 and 7. That's all. So, what do you say from 1 and 2? This is equation number 2. From 1 and 2, you can say that from 1 and 2, you can say that LHS is equal to RHS. LHS is equal to RHS. That is, A union B union C is equal to A union B union C. That is, associative law is satisfied. Similarly, you can verify this intersection also. If you want, you can verify the intersection also. Let me take the intersection part. First, write down B intersection C. I'll write B intersection C. The common element in B and C, the common element in these two is, so 2 is not there, 3 is also not there, 4 and 5. So 4 comma 5 is the common element. And A intersection B intersection C, the elements which are common in both A as well as in B intersection C, 1, 2, 3 and 4, 5. See, 1, 2, 3 is there, 4, 5, nothing is there. This is a null set. Now, similarly, on the other hand, find out A intersection B. I'll write here A intersection B is equal to A intersection B, A intersection. So, the elements which are common in A and B is 2 and 3. Right. Then, right hand side A intersection B intersection C. The elements which are common in this A 2, 3 and C. See here, C contains 4, 5, 6, 7 and A intersection B contains 2, 3. No elements are common. Again, this is a null set. So, what do you say? A intersection B intersection C is equal to A intersection B. In this case, is a null set. This is how we are going to verify the associative property in case of union as well as in case of intersection. Okay. Now, let us take the problem based on this. Now, let us take if A is equal to 1, 2, 3. A contains 1, 2, 3, 4, B contains 3, 4, 5, 6 and C contains 5, 6, 7, 8. Verify the associative laws. Now, we have to verify both the laws. First, come to the union of laws. What is first law says? First law is A union B union C. So, A union B union C is equal to A union B union C. Now, straight away I will write what is A? A contains 1, 2, 3, 4 union B union C. Write down the union for B and C. B contains 3, 4, 5, 6 and in C 5, 6 already repeated. You can take 7, 8. So, this is nothing but the union of this. So, the union of this is 1, 2, 3, 4, 5, 6, 7 and 8. This is, let us represent this LHS equation number 1, LHS. Write this RHS. What is RHS? A union B union C. A union B, union of A and B, that is 1, 2, 3, 4, 5, 6. Then union of C. C contains 5, 6, 7, 8. That is 1, 2, 3, 4, 5, 6, 7, 8. See the equations 1 and 2. From 1 and 2 we can say that LHS is equal to RHS. From 1 and 2 LHS is equal to RHS. Therefore, A union B union C is equal to A union B union C. Now, intersection, I will go to the next page to prove the second part, second one. What is to prove? A intersection B intersection C is equal to A intersection B intersection C. Now, first write down B intersection C. The common element in B and C. The common element B and C is what it contains 5, 6, 5, 6. So, this is 5, 6. Now, LHS, I will write LHS A intersection B intersection C. So, what is A contain? 1, 2, 3, 4. 1, 2, 3, 4. Intersection B intersection C contains 5, 6. What are the elements common in these two? Nothing is there. This is a null set. A intersection B is a null set. Now, on the other hand, come to the right hand side. RHS. RHS is A intersection B intersection C. Now, A intersection B, the common in A and B is 3 and 4. Intersection C. C contains 5, 6, 7, 8. 5, 6, 7, 8. Now, what are the common elements? This contains 3, 4. Here 3, 4 is not. Again, this is a null set. Both are null sets. So, therefore, we can say A intersection B intersection C is also equal to A intersection B intersection C. This is how we are going to verify the associative laws. Hope you followed. Okay. Now let us come to the next one, De Morgan's law. This is very, very important. If A and B are any two sets, if A and B are any two sets, then A union B whole dash is equal to A dash intersection B dash. If you take the complement of union, so that is reversal of A union B. A union B is equal to A dash intersection B dash. Reversal laws, that is A union B whole dash is equal to A dash intersection B dash. Similarly, A intersection B dash is also equal to A dash union B dash. These two are called as the De Morgan's law. So, A union B, now here if A and B are any two sets, then A union B whole dash is equal to A dash intersection B dash. Reversal law of complement. Similarly, A intersection B whole dash is equal to A dash union B dash. These are called as the De Morgan's law. Very important. So, you may expect one questions on De Morgan's law. Just write down A union B and take the transpose A minus A union B whole dash and A dash intersection B dash. Verify they are equal or not. Now, let us take a small example. Now, what is given here? Let U is equal to 1, 2, 3, 4, 5, 6, 8, 9. 7 is not there. Now, let us verify the first one, De Morgan law. First one, what is to verify? A union B whole dash. A union B whole dash is equal to A dash intersection B dash. Now, first write down A union B. A union B is nothing but all the elements which are in A and B. A contains 1, 2, 3, 4, 5 and B contains 3, 4, 5 is already there, 6, 7. A union B is equal to 1, 2, 3, 4, 5, 6, 7. Okay, then A union B whole dash. A union B whole dash is nothing but U minus A union B. All the elements which are in universal set but not in A union B. The difference of U and A union B is A union B whole dash. That's all. So, since A union B contains 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Here, all the elements which are in U. See, 1 is there, 2 is there, 3, 4, 5, 6 is there. 8 and 9 are not there. See, this is 8, 9. So, A union B whole dash is equal to 8 and 9. Similarly, come to the right hand side. This is LHS part. And whereas on the right hand side we have A dash intersection B dash. So, A dash is nothing but U minus A. What is U minus A? All the elements which are in U but not in A. So, in A 1, 2, 3, 4, 5. So, you can leave this 1, 2, 3, 4, 5. What is left over is 6, 8 and 9. Similarly, find out B dash. B dash is nothing but U minus B. U minus B means all the elements which are in U but not in B. In B we have 3, 4, 5, 3, 4, 5, 6. So, 8 and 9 are not there. 8 and 9. Okay. So, A union B, U minus A, all the elements which are in U. That is 1, 2, 3, 4, 5. Other than 1, 2, 3, 4, 5, 6, 8 and 9. Similarly, B dash is U minus B. 1, 2, 3, 4, 5, 6, 8, 9. In that, these are the elements. You can leave this 3, 4, 5, 6 and 7. Remaining are 8 and 9. So, then what is the right hand side we have? On the right hand side we have the intersection of these two. A dash intersection B dash. So, the intersection in these two. What are the elements which are common in A dash and B dash is 6 is not there, 8 and 9. 8, 9. Let us represent this as equation number 2. What do you say? Therefore, from 1 and 2, we can say that LHS is equal to RHS. LHS is equal to RHS. That means A union B whole dash. A union B whole dash is equal to A dash intersection B dash. That's it. Okay. This is how. So, if you solve this, definitely you will get 3 marks for the point of examination. Sometimes, if you verify both the properties, you will get 5 marks or 6 marks. Now, let us come to the second one. Second one is the intersection. So A dash intersection B dash A intersection B dash is equal to A dash intersection A dash union B dash. Now the second one, to prove that A intersection B whole dash is equal to A dash union B dash. Already we know what is A dash A intersection. Find out first A intersection B. A intersection B is nothing but the common element in A and B. The common elements in A and B are 1, 2, 3, 4, 1, 2, 3, 4, 5. So 1, 2, 3, 4 and 5. Now complement of this A intersection B whole dash is nothing but U minus A intersection B. All the elements which are in U but not in this. So in A intersection B I have 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Other than this, we have 6, 8 and 9. Let us represent this as equation number 1. Next, right hand side. Now, A dash union B dash. Alright, again, A dash union B dash is equal to, what is A dash? We have A dash is equal to all the elements of A dash are 6, 8, 9. 6, 8, 9 union B dash 8 and 9. The union is nothing but 6, 8, 9. 6, 8, 9. This is equation number 2. Now, what do you say from this 1 and 2? Therefore, from 1 and 2, we can say that from 1 and 2, LHS is equal to RHS. Therefore, you can say that A intersection B whole dash is equal to A dash union B dash. This is called De Morgan's law. Very, very important. So if you do this much, definitely you will get 6 or 7 marks in the examination. Very important type question. So that's all regarding the properties and operations on sets like union, intersection and difference, complementation, symmetric difference, and as well as the properties like commutative property, associative property and De Morgan's property. So that's all regarding this session. Let us meet with different concept in the next session. Hope you followed. Thank you very much.